Code now. Okay, so as I said that in this class we want to focus on math 1120 tutorial sheet 1. So we're having a continuation. We start from question 4 because we ended on question 3 last time. Question 4 reads, let x equal 2. So that is the interval or the set. Negative 10. It is closed because there are square brackets on both sides. Be the universal set. Then given that A is equal to that there, and we have B there, and C given, find the following sets and display on the number line. So they're telling us we must find these sets and also display these sets on the number line. So how do we find these sets and how do we display them on the number line? Okay, so let us first have a general plot of what we are looking at. So we have this line here, and we'll call this line, which is going to be our x, which is the universal set, and this line is going to move. So we see that it's closed on both sides. So it is closed on both sides. So we see here at this side, which is negative 10. This is negative 10. And on the other side, it is also closed, which is positive 10. It is closed like this. And this here is the universal set. Then we are given that the set A is from negative 2, then up to what? 7. And it is open on both what? Both sides. So for this set, so I'll say if my negative 2 is somewhere, maybe somewhere here, and I have my 7 somewhere there, my set A is going to be open here at 2, and also all the way, so all the way, let me use a different color here. So I'm saying all the way up to there, it's going to be what's to be open like this. So that's how, and here at what? It's open at 7 as well. It is open. So it is open at negative 2 and also open at what? At 7. Then we have the set B here, which is given by, okay, so it's negative 6 to 6, then union the set that is 8 and 9. Union 8 and 9. That is the set B. So now, how do I plot that? So I'll say, let's say my negative 6 is somewhere here. So here I'll put negative 6 and my positive 6b somewhere there. Okay. So when it comes to plotting, it is closed on both sides. So it is closed here and it is also closed there. So this here is the interval that I'm having, and I'll put it in white. So that is the set B. Okay, just a minute. Set B there to there. Okay, so that's the set B. Then I have that my set B is also union these points here, these 2 points, that is 8 and what? 8 and 9. So if my 8 is here and my 9 is there, so union these points. So what I'll do is, okay, on this one, let me shade these end parts with white, just to indicate that this is the set, differentiate the two. So this is the set B, and also on the points that is 8.8 and the point 9. So these points, so these numbers, just 8 and 9, are the ones that are in this union of set B. So the numbers in between here, numbers that are in between 8 and 9, are not part of the set B, but only the number 8 and 9 are in the set what? B. Okay. So now the next one, C is just so C is 3 and 10 there. So like that. And if I display that on the number line, I have 3, where if I say my 3 is somewhere here and my 10 is already there, and displaying this, it is open at what? At 3. So I'll open it here and it goes all the way up to 10, all the way up to 10. which is like that. And it is what? It is closed at 10. So at 10, I'm going to shade. Okay, at 10, I'm going to shade in here. So it's going to be like that. So these are the sets that I'm having. So the one in yellow, that is my set A. The one in white, that is our set B. Then our set C is the one in blue. And they're telling us to find the sets. So we must find. So the first one which we're finding is C minus B, the set difference of C and B, which is just the same as saying C intersect B complement. C intersect B complement. So now how do I indicate this? So I can actually find this C intersect B complement without even plotting first of all. So if I look at this, my set C, so set C I already have. Set C I already have, and it's this interval here. That's 3 to 10, like that. That is my set C. Then what is my B complement? So remember, B, the complement of a set is just the elements that are not in that set but sit in the universal set. So now our set, our B complement. So our set B is in white. Our set B is in white. Remember, they are the one in white. I'll write our B complement in yellow. So that you see, I mean in green, so that you see the difference. Now, when we look, so everything that is not in what in set B. So here from this point where there is what there is 6 going this way, include then up to what up to 10. So I shade that in. So 6 is not in the complement since 6 belongs to the set what to the set B. So meaning where there is 6 here, I'm going to have an open interval like that. It's going to be open. Then I go here as well. That is where there's -6. And where there's 6 on the other side, again, it's going to be open, meaning 6 is not in the complement. So this here will go all the way up to, so we'll go all the way up to, okay, sorry, just a moment. Yeah, to go all the way up to where 8 is. But 8 is in that set, so at 8 it's going to be what? To be open, like this. Then the numbers in between here are also in that. So here in between it will be there. Then at 9 it's going to be what? To be open. Then from 9 to 10, the numbers there like that. Then it's going to be closed at 10. It's going to be closed at 10 because it's going to be a part of that. So the one that I've written in green, that is B complement. So if I was to write that from starting from the left side, because we're starting from the negative side going to the positive side. So the negative side means we're going to say that -10 like that, and the interval goes up to what? 6. So I'll say -10, comma, -6. Then at -6 it's going to be open like that. Then union. So union, what point is next? That's 6 all the way up to 8. 6 all the way up to 8, and at 8 it is what? It is open like that. Then union again. Then union, I was saying that from 8 to 9, 8 to 9, then union again. If you see union, that's from 9. So all right, I continue here. That's 9 all the way up to 10, and at 10 it is closed like this. So this is our B complement. So this is our B complement. Okay, so now having found our B complement, it's just important to note that. Then they're telling us our focus is C intersect B. So C intersect B. Our set C, if you check, what is our set C? Our set C is this one in blue. That's our set C. So what we must check is where does this blue set here intersect with the green set? So if I was to write here, I write a dotted line going there, and I write another one that is separating here, there, and there, like that. So now, if I check this here, these elements that are in between here are the same. They are the same for both of these sets. That's for set C and for set B complement. So now, when I look at B complement, at the point 6, B complement has an open interval, meaning 6 is not in what? Is not in B complement. And if and if 6 is not in B complement, meaning it cannot intersect with what? With a 6 which is in the set C. So meaning as we are going to start here, our intersection, so that means our intersection there, where at 6, it's going to be what? To be open, because we see that there's an open interval here, and 6 is not part of the complement, meaning it can't intersect with the 6 that is in set what? That is in the set C. So here it's going to be open like that. Then we see it goes all the way up to what? Up to 8. So when it goes to 8, and at 8 again, it is what? It is open at 8. So meaning 8, here I'll come, comma what? Comma 8 like this, and to be open at what? At 8. It intersects still even here in between. That is union. You say check union from 8 towards to 9. It's intersecting, but these all have open points here. So meaning 8 and 9 are not part of those sets, but the numbers in between 8 and 9 are intersecting with what? With the numbers that are in the set C. Then union, the last point now again, which is just 9, comma, 10, and open at 10. So this is what is going to be your C intersect B complement. And in other ways of just thinking about it, when you see the set C here that is given, that C minus B. So C minus B is saying the set difference of C and B, that is just all elements that belong to the set C, but are not in the set what? In the set what? B. They belong to the set C, but are not in the set B. So, okay, did I say that right? Yes. So now, when you look at this, this is our C intersect B complement. C intersect B complement. I don't know if I have any question here, but this is how you find that this set here. This is how you find this set. So here, this, if you see from what we found, that this is the intersection of what? Of the interval that which we had, and it, it solves that question which we're having, which is the first part of the question. And then they're saying, when they said find each of the following sets and display what on the number line, I think this is then easy to display on the number line. So check out now. We're saying you have here, we're moving from -10, and that side it is 10, and we see that from what we just found, our that's, we move 6 to 8, 8 to 9, and 9 to 10. So that is, if I have my 6 here, have my 8, and I have my what? My 9. So that is going to be open there. Then it goes all the way open there, goes, and it's open there, and it's just going to be closed at that last point. So this is how you would plot the final answer, or the last value that you get. I don't know if we have any question. Is anyone behind at this point?
I'm very behind.
Okay. Where exactly? I can.
Sorry, but from the very beginning, I just left the app because of the disconnection.
Okay. Okay. That is not a problem. We are at liberty to just repeat what we're saying. So first of all, we've been given these sets that we have, and we have set X that goes from
Yes.
-10 to 10. all that there, and these are the sets. So first thing, you plot the sets. Set A goes from -2 towards to 7, and we see that it has these kind of brackets, and whenever these are used, what that means is that the endpoints 5A and B here, these will not be part of what of that interval that I have. So you have to put an open what interval, which is just a circle, and that is not shaded in. And as you can see here with the yellow one, we didn't shade it in. Then when we moved on to part B, so B runs from -6 to 6 and union the set which contains 8 and what and 9. So from -6 here we moved to 6, and we shaded in these parts because they have square brackets, which means 6 and -6 and 6 are part of that interval. So I shaded in there. Then when it comes to union these sets, that if including the set that has 8 and 9. So 8 and 9 are just points, like there's 8 there and there's 9 there. So remember that in between this interval here, which is left blank for us to reach 8, and this here in between, there are values that are there, but those values are not part of the set B. That's why we didn't put a line up to there. So we just put those points 8 and 9. Then when it comes to C, it is what? It is open. So we see it's open at 3 and closed at 10. So we moved from 3 to what? To the set 10. Then we know that the first one that we're told to find, C minus B, is the same as C intersect B complement. So C intersect B complement, we already have the set C, and we've plotted that set C. Then B complement, we can find B complement because we understand that the complement of the set is just all elements that are not in that set but sit in the universal set. And our universal set is running from -10 towards to 10. So meaning if our set B is here, it is shaded at -6. So meaning -6 is not going to be part of the complement because it's in the set B. So meaning it won't be in B complement. So that's why we leave an open interval there. Then we go up to what? Up to 10, and we close there where -10 is. So this here, the in green, is what? First part of the complement. We do here again, why the 6? 6 is in the set B, meaning it won't be in what? In B complement. So we leave an open interval at B complement. The numbers here in between are what? From 6 to 8 sit in the complement because they're not in the set B. So this here, we'll write a line there. Then going 8 is in the set B, meaning it won't be in the set what? B complement. So we leave an open interval, so to be just an open circle there. There are numbers in between. In between 8 and 9, there are a lot of real numbers that are there. So you can go, there's 8.1, 8.1. Like there are numbers that are there. There are a lot. So now that's that line which is just going in between there. So that it means this the numbers in between 8 and 9 are going to be in B complement. Then from 9 to 10. So from 9 to 10, the numbers there, including 10 this time around, is what is going to be in the complement. So this here is going to be the complement. But remember the question is C intersect B. So now you check where is my set C? So my set C is the one which we wrote in what? In blue. Then they're telling us where do these, you check where do they intersect? In short, where are the common elements? Where are those common elements that are in both set C and in B complement? So when I check those elements, I see that the ones that I'll end up with are here. So 6 here, what I was saying is 6, it's open at 6. 6 is not in B complement. So it can't intersect because it's not in B complement. That's the reason why we have an open interval here at what? At 6. Then it goes all the way, the numbers in between up to here at 8. 8 is also not in what? In B complement. But it, of course, it is in C, but it's not in B complement. So it can't intersect. That's the reason why we leave it open here. But the numbers in between, so meaning the numbers between 8 and 9, they intersect. So we write it like that. Then union, you see here from 8 to 9, again, the numbers in between intersect. Then again, union from here 9, then we're saying the numbers in between 9 and 10, including 10 this time, is going to intersect. And this here is what is going to give us our final answer. So this is what we get in red. This red oasis is our final answer. And when we check that, I was saying we can plot that. If you plot it like this, it's just going separate. This is just the answer alone. It will look like this. I don't know now if it's clear.
It is clear.
All right, thank you very much. So let's move on to the next question which we have. So I'll erase this part. I don't want to erase this diagram because we've put color on it, so it's going to be of help to differentiate the sets. Okay, so just allow me to erase this part. That's I just remain with the sets that I had written at first. Okay, so all right, so let me write back. I'll write back. Okay, that has to be in white. I'll shade in again. That is 8 and 9, like this. So okay, now the second one. The second one is B. So they're telling us B, that's minus, then intersect C. And when you check this is the same as saying B intersect A complement intersect C. So B intersect A complement intersect C. So you're at liberty to just even work out what is here in the bracket. Work out what is in the bracket, then intersect it with what we see. And actually, you can even get this. So it's easy when you're looking at it from the diagram for you to actually see what you're trying to find. So you can sketch. So you can sketch this B intersect A complement, even separately, just to see how it is. So, but we'll do it on this diagram for the sake of time, and all, we'll do it on this diagram. So in this diagram now, we want to see, they're saying B, we already have B, and B is in white. Then they're telling us to intersect that with A complement. So our set A is the one in yellow. Then what is going to be our complement? So our A, if our A is from this is our A here, that's -2 to 7, meaning our complement will first go, -2 is not in A, meaning -2 will sit in the complement. So -2 all the way up to what? -10. This here is going to sit in the complement. Then union, of course, 7 is not in A, meaning it's going to be in the complement all the way up to 10, like that. So if I is to write this, that means from here all the way up to -10, then from 7 all the way up to 10. So this is our A complement. Then they're telling you to intersect this with B. B, remember, B is the one in white. B is the one in white, in white. So where do these intersect? You must check now, where do they intersect? So they intersect one here. When you check from here to there, this point here, they intersect. So including what, where -6 is. So you have -6 to intersect -6 all the way up to -2. So all the way up to -2, it's going to intersect. Then for this part of B intersecting, it intersects with 8 and what, and 9. You see these 8 and 9, they are also in this set there. So union, union what? That is union the set, meaning containing 8 and 9, since those are just points, 8 and 9. So this is what you have to be A intersect, that's to be B, I mean B intersect A complement. Then you have to intersect this with what? With the set C. So now let us write it, or let us draw it separately. So let us draw that separately. So if we have this here, moving from -10 and to 10, then we had that the intersection was -6 to -2. So that is from here, it's included, and all the way up to -2, it's included. Then it's also intersecting at 9 and also at 8. So meaning these points here is intersecting. So this here is our B intersect A complement. That's our B intersect A complement. Then they tell us we must intersect this with what? With the set C. So now the set C, remember, is from 3 to 7. 3 to 7, if we check well, it's given here. 3 to what? To 10, I mean 3 to 10. So this has to be 10, not 7. 3 to 10, and that 10 is what is included, is part of that interval, and we wrote it in blue. So now, allow me to use a different color. Let me use red this time to just plot that. So let's say if our 3 is here, then all the way up to 10. So 3, it is open at 3, then it goes all the way up to 10, like this. So now that, where does this intersect? Where does this intersect with the blue one? So if you check, it just intersects at the point which is 8 and what, and 9. Those are the points where it intersects, which means that the final answer now, B intersect A complement intersect C, is just going to be equal to the set containing 8 and 9, since this is where the intersection what is. And if you just plot this alone, you see that from negative 10 to 10 there, just have your points 9 and 8, of course, and it's just going to be 2 points like that. Yeah, so this is how you find your answer and go about the plot. Do we have any question here? Okay, so we are together. So now let us, is that a question?
I have a question.
Yes.
Are we also supposed to, okay, when writing, when answering the question, are we supposed to use different colors as well?
No. You don't have to use different colors. I'm just using different colors for you guys to clearly see it and to just differentiate and easily just get it. But yeah, you just have to use one pen. Yeah, just use one ink. Yeah. Okay, so in
Oh,
case,
okay, thank
sure, in case this video cuts, of which it's going to, just rejoin using the same link. So let's continue with our question. So which one should I watch this? Let me just do one more on this one, just that we move on to the next one. Which one should I answer? Which one should we answer?
Question E.
Okay, let's do E. So E, okay. So E, what does E say for us? So E, if we check, E is X minus C complement intersect A minus B. So I always find it easy if you just do it in bits and pieces. Yeah, it's going to help. So if I write this, I can write this as X intersect C complement there, intersect A intersect B complement. And this complement can distribute there so that I have X complement. Then this sign flips from intersection to union, and I have C like that. Then here in between intersector, A intersect B complement. So this is what I'm trying to find. Just this at the bottom there is what I'm trying to find. So your X complement. What is your X complement? So X, remember X is our universal what? Universal set. So anything outside, what is anything outside the universal set? If we are just working within the space of the universal set, and when we say X complement, that is going to what? To equal the empty set, because our space of working is what? Is the universal set, and that universal set has to contain all the elements. So meaning if the universal set, we're finding the complement of the universal set, and by definition of what a complement of a set is, are those elements which are not in that set but sit in the universal set. And will there be any other elements that will not sit in the universal set? There will not be. So meaning X complement is just going to be equal to the empty set. So X complement is the empty set. So we know that this is empty set union C. So the first part here is just the empty set union C. So we know what C is. So in short, when you unite the empty set and C, you just get the set what? The set C. So meaning on this left side, we're just ending up with what? With the set C. Then with this other side, the other side, we have A intersect B complement. So we had found our B complements, and of which I can write that again. Okay, just erase this such that we write our B complement again. So I'll write it in green again. So our B complement, we say it was open here, then it goes there, and it's closed there. Then it is what? Open here, goes open there, goes open there, and it is closed at that point. So that's my that is my set, that's my B complement. And where does my B complement intersect with the set A? So where is my set A? My set A is the one in yellow. That's my set A, the one in yellow. So if I check, meaning from here coming down and from where here, like that, this is where my intersection is supposed to be, this region there. So I see that at 7 here, where 7, which is in the set A, it is open. It's not in the set A, I mean, it is open there. Though it sits in the complement of B, but it's open there, which means it's going to be what? To be open as well in our intersection of the two. So it will be open there. Then here, when I check, it is open there at 6. 6 is not in B complement, so meaning it will not intersect with the 6, which is in the set A. So meaning we just get that this here is A intersect B complement. That is going to be our A intersect B complement. So now we have, so we're just now, so intersect here, remember, intersect, then what we had here, we just found C. We just remained with the set what? With the set C. And the set C is running from 3, we know, it's going from 3 to 10. 3, so 3 to 3 10, and it's included at 10. So if I check that, I can even plot this separately just to get a clear view of what is going on here. So at -10, and we have 10 there. So we have that 3, or the set C, which is 3 to 10. So it's open there. So it's open at 3, and it is what? Closed at 10. So it's like that. Then the other interval which I had was 6 and what? 7. So that is 6 and 7 here, and it is open on both sides. Then they're telling me where do these two sets intersect? And of course, it's clear that they intersect here, but of course, 6 and 7 are not in there because it's open on 6 and 7. So it's going to be 6, 7 like this. And this here is going to be the value for, this is the answer for this, for part E. Yeah, part E, which we got. This one here is just, in short way, our answer will just be 6, 7 like that. And this, of course, is plot it's easy just to plot it alone. All right, so we've answered question E. Then I guess we'll move on if there are no questions. Are we clear?
Yes.
All right, thank you. So, okay, so we have this one, and it's they are telling us, given that the set of real numbers is the universal set, then we have the set A and the set B equal to that. Then they're telling us to find each of the following and show them on what? On the number line. So we find them and we show them, of course, on the number line, like we have been showing. So now, again here, let's just pick 2. Which one should we do? Let's pick 2. for the sake of time, just that. Which one should
B.
B?
B and D.
Okay,
B
so
and D.
B and D. Okay, B and D is what we're going to do. So let us plot the what's this, the graph first of all. Not the graph, the number line. Okay, so it's going. They say that the universal set is the set of real numbers, meaning it's going from negative infinity all the way up to positive infinity, like that. Then our set A is from negative what? Infinity up to 7. Negative infinity up to 7. Let's say our 7 is here. And it is closed at 7. If you check there, it's closed at 7. Then, of course, it had gone from negative infinity like that up to 7. So this arrow just shows us that it continues to go up to negative infinity. Then union 9. So if I say my 9 is here, 9 all the way up to infinity. So it's open at 9, and that goes up to infinity like that. So this is what we have. And then my B is from 5. So let's say 5 is here. It's closed at 5, and it goes all the way up to positive infinity. That's like that. So now this is what we get, and we have to find, first of all, that is A union B complement. So to find this, going to be, yeah, it's going to be easy. It won't really be hard, because you can first find A union B. First find A union B and do the complement of A union B. So what is going to be A union B? So A union B, we are bringing all elements together that are both in the set A and in the set B. And if you've gone ahead of me and you're seeing what I'm seeing, A union B complement is just going to be, they've told us to find A union B. So here, when we look at the set A, the set A goes from negative, infinity all the way up to 7, Then here it's closed like that, and then uh, it then there's a union. There's a union. So I'll leave the union like a gap. I wanna leave a gap there in between. Then I say from it's open at 9 and all the way up to infinity like that. Now, when you look at the set B, the set B is given that it goes from 5. So 5 actually is contained in here. So 5 is there, right? 5 is there, and of course it's closed at 5, and it's going all the way up to what? Up to infinity. So meaning here, we're up to infinity, meaning the 9, which was not catered for in set A, meaning will be in the set B. When we bring all this together, what we're just getting is a set going from negative infinity all the way up to positive infinity. And that is just the set of what? Of real numbers which we have. Now, we are working with the space of real numbers. Like real numbers is our universal set. And now, if this is our A, if our A union B, our A union B is the set of real numbers, which is just the set running from negative infinity to positive infinity. When we say A union B complement, we add a complement to that. What is going to be outside our space that we are working in? So we are restricted. Our space is the real numbers. So complement outside there's going to be what? There's nothing, because we're just working in the space of what? Of the real numbers. So meaning A union B complement, this is just going to be empty. It's going to be equal to the empty set. And you showing that what's this is just going to be like that. You can write it even like that. It's going to be an empty set. That's what we're going to have. Okay. Doing part D now. Part D. Our D is B complement intersect A minus B like this, and this can be written as B complement intersect A intersect B complement like that. This is what you have. B intersect. Okay, so now how are we going to do this? So when you check here, what is your B complement? So my B complement, if my set B is this one in yellow, B complement is going to be open at 5, and it's going to go all the way up to negative infinity there. Then my A, of course, is the one in white. Then they're telling me these I should intersect this. Where does that intersect? So where it intersects, if you check, it intersects here like that, and 5 is not part of that intersection. 5 is not part of that intersection of A. So meaning it's going to be from negative infinity all the way up to 5. So now negative infinity to 5. And of course, this again, they're saying this, what we found, we're intersecting it with what? So it implies B complement. They're telling us we intersect it with B complement. But when we intersect, it's going to still give us this one because B complement is the one which is in red. So meaning this set is just going to be B complement intersect A minus B like that is just going to be equal to the interval negative infinity to 5 like that, not included. And of course, on number line, this just looks like we have 5 there. It's going to be open and all the way up to infinity like that, negative infinity. So this is how your set B complement intersect A minus B like that is going to look. Okay, so we are done with this one, unless there's any question.
The meeting had cut.
The meeting had cuts.
Yes, so we've just gotten the end part.
Just gotten
The end part.
the end part of D.
Yes.
Okay, like from the moment I started explaining D, you didn't get anything?
No.
Oh,
I got the first explanation, but then the meeting had cut.
oh yes, it had cut. So when it cut, I was waiting like for you guys to rejoin. So there's nothing you've missed. Yes. At
I'm
first,
saying
uh-huh.
yes. Just now.
Oh, just now. Okay.
Yes.
So I should re-explain question D.
Yes.
Okay. So I re-explain D. So D, what we are saying, where D is concerned, we have that it's given by B complement intersect A minus B like this. This is somehow called, what do you call it? Is it the law of absorption? Something like, or adsorption. I remember my tutor when I was in first year was telling me something like that. But yeah, always when you see there's B complement there, for example, intersect, I can write what is inside A intersect B complement. Remember he told me always when you see there's a B complement here, not a B complement, there's a set here and there's an intersection, then there's another set inside then there's an intersection as well. Like there's the same set here. Like we have this B complement and there's B complement. This just simplifies to B complement. That's what this kind of rule he was trying to emphasize. So when you check what B complement is, so the set B goes from, so set B is 5 all the way up to infinity. So then B complement, meaning what is not in here. So 5 is in here, so meaning 5 will not be in the complement, to be open there. But the numbers from 5 going up to negative infinity there, these here will sit in the B complement. And if we check, this is the plot which we have here in red. And that is what we just get, because it simplifies just to B complement like that. So this here is going to be your answer. And I was saying you can actually plot that to say, when you plot it separately, you just have a line, negative infinity, positive infinity. You have 5 there, it's open there, and it goes up to infinity, the arrow like that. And this is a B complement intersect A intersect B complement, or the way it is given in the question, which is just A minus B. The set difference of A and B, like that. Yeah, I don't know. Are you clear on this one now?
Yes.
Okay, so let's move on. We have these questions. Again, due to time, which one? 2. We will answer 2 of these. Anybody to choose? Which one should we answer? We will answer 2.
C and D.
So we choose C and D. C and D. So they're telling us, given that X and Y are sets, simplify the following further. So C we have, so remember this here, there's a big bracket in short. That's, then you have X complement union Y intersect X close, then there's a complement. So here, when simplify, we first distribute that complement. So when I distribute the complement, this complement here with the one where there's X complement, meaning the X complement there goes and I just remain with X. So this sign then flips, it becomes intersection, then my Y intersect X complement. This set then will have a what? Will have a complement like this. So this is what I get there. So after getting this, what then can I do with this? What then can I do? You can even see this in your Venn diagram. What does this mean? You have your two sets sitting, X and Y. So that's your X, that's your Y. Y and X intersect at what point? This point here in between. That's where they intersect. So meaning the complement of this is going to do what? Anything outside that intersection in between there. So anything outside here that is not going to be part of there, this here is going to, apart from that middle part, this here, the entire thing is just all this is going to be our Y intersect X complement. Y intersect X complement. Then they are telling you that intersect this with the set Y. Intersect this with the set Y. X. Intersect this with the set X. So I shade the entire set of what? Of X. So the entire set of X is that one. We're intersecting. That's the entire set of X. Then I check, where do these lines, the red ones and the white ones, cross? Where do they cross? So where they cross, I to draw it separately, I have 1 and 2, X, Y, they just cross at this point. So how can I describe this set here which I have? So that set is just going to be, if you check, that is just Y complement intersect X. Y complement intersect X is that set which is there. Y complement intersect X. So meaning this here does simplify to, Y complement intersect X. Okay. Now, we can also ask ourselves, can we get it in another way? Can we get it somehow? So let us try. So I didn't try this one, but let us try using De Morgan's law here. So De Morgan's law says this here, Y intersect X complement is going to be the same as Y complement union x complement. This is going to be the same. So meaning we will have x intersect, then I have y complement union x complement there. Then I can use the distributive law where I distribute my x intersect here. So I have x intersect y complement like this. Then union, this here goes to x intersect x complement. So now I have to check. This here I know this. When I have x intersect y complement, draw your set like this. Let's say I have your set, this is your set x that sits there. Your x complement is everything outside what the set x. And your set x, of course, is this one inside here. And you see that, I write it in red like this. So the one in red is x. The one in blue, shaded in blue, that is x complement. And these here do not intersect anywhere. So I have union, and that would mean that would give me the empty set. And of course, here what I have on my left side, I'll just end up with the same x intersect y complement like this. When I unite this, just gives me x intersect y complement. And we see that this is the same answer by logic that I use. So this one, the first part of it that I showed you, this one here is when you're just trying to maybe get the answer more fast or anything, but you'd rather go this approach and you show the entire work where you do the De Morgan's law, then you do the set distribution, then you conclude it like this up to here. I don't know if that is clear. Okay.
Yes, it's clear.
All right, so let's do D now. D, okay. D, I think I will make D the last question because I have another class after this one. So D, what is D? When we look at D, we have x intersect y union x intersect y complement. So this is what I have, x intersect y union x intersect y complement. And here, this is really, if you can see, you have an x, you have a x intersect here and x intersect there. You can factor out that. You factor out that, then you have your y here, union, and the y complement there. This is what you're going to have. And checking this here, draw my Venn diagram here. I'll just write the set y alone, just for demonstration's sake. You can write it both with y intersecting with y, there's no problem. So this is your y. So your y is this inside, values that will be sitting in the set y. Then your y complement is everything outside here. So now there's union. So you're bringing all that together. And when you bring all that together, this will just be the entire set, this is going to be the universal set, because you see we're shaded in the universal set like that. So this is what I get the universal set. So here I'll have E intersect X. Remember this set algebra, X intersect E is just going to us intersecting with the set X. So if I had written set X here, let me write it. Set X like this here. What set X means, they're saying here intersect set X. So I didn't write X, it's supposed to be X. So intersect X, I shade the entire set X, and I see where do these lines cross. And these lines are crossing on the entire set of X. So meaning here, this I just conclude that my value, or this simplifies up to the set X. So that's where it ends. This marks the end of this class. I don't know if there are any questions. Okay, that's silent. So now I leave this one as a question you guys must try. You can send it to those that to manage to solve it. Send it to my inbox, and I'll confirm to you if it's right or wrong. This is question 7, and in the tutorial sheet for that's 11:20. It's the last one that just deals with things like Venn diagrams, like drawing the number line and everything. The next time we look at tutorial sheet 1 of 11:20, we'll be looking at rational numbers and complex numbers. So this is in short, we're done with the set theory. You answer this question as an assignment just to do it. Okay. Thank you very much. If I have no question, end here.